Safety. Ingrained in all our solutions, a promise of simplicity, flexibility, reliability, and security. A system that will work for decades. This is our core mission at DAM, built into the foundation of all our solutions all over the world. Dealing with transit systems and infrastructure that transports millions of people and millions of tons of goods each day, our technology makes communication and management smooth and reliable. Designed on our principles, one software, one hardware, we keep it simple and scalable. Our solutions have no single point of failure, so should one base station fail, the network compensates, remaining fully operational. Managing a train network or dispatching employees, our solutions ensure instant, uninterrupted communication, which empowers you with the speed and reliability you need to keep operations running smoothly. Plug-and-play design and flat, decentralized IP architecture ensures not only effortless, self-configuring scalability and easy maintenance, but minimal operation and maintenance costs. We provide a secure, critical voice and data communication solution in a time of increasing security threats. Whether in densely populated areas, rural, harsh, remote locations, or underground, we deliver complete coverage. This is our promise of simplicity, flexibility, reliability, and security. Our deep commitment to give you safety.
And it has been a providing various communication systems to railways and metros in this country for quite some time. And we have been focusing on TETRA, 4G, 5G, and FMRCS networks. And we're also developing various solutions on the 4G, 5G networks as well as FRMCS networks. We have more than around 100 critical networks in place today in this country. And the very good thing about this is that the train radio or the train component of this TETRA communication is built in India and under the Atmanirbhar Bharat initiative. And the dispatching solutions also, which are required at the control centers, the OCC, POCC is also made in this country today. And it is also presently developing a particular software-based switch, which is called MCX1, which is a very critical component of this overall network and which integrates basically to other subsystems like the TCMS, ATS, etc. So we'll come to that slowly. And we have also formed a joint venture with DAM in India. It is called DAM India, and where there is a partnership between DAM and Consort to work on TETRA networks and other futuristic communications which are required. Okay, regarding the overall bandwidth of this company, we deal in TETRA radio communications, as I said, and we have more than 100 different big customers where we have deployed networks in India, as well as in neighboring countries like Bangladesh, Mauritius, etc. So there are also TETRA networks which have installed for these countries for railway applications. There is a new standard called FRMCS, which is Future Railway Mobile Communication System. And we are the only company from India to participate in the FRMCS tests, which are conducted for interoperability with different systems. And besides this, so we are also working in LTE-based systems in the sense that we are providing dispatching solutions as well as the train radio solution, as also the station radio solutions which are required for a LT activity. And we are presently deploying a similar solution in Dhaka Metro, which is whose backbone is fundamentally LTE. Okay, now the fundamental difference between a normal communication network and a mission critical communication network is that you have to guarantee coverage, number one. And when you talk of guaranteed coverage, it also means that in case of any particular failure, the coverage should also be there. That means you are talking of redundant coverage also. So when you build up a network, so we bring in those kind of resiliencies, if those kind of RF planning is done. So even if one BTS collapses, the network should be consistent. Okay. The second is it should be instant and reliable. By instant and reliable, we mean that you should be able to get resources or channel allocated when you want it. So we have situations when customers have been using GSM networks or the present public networks, and whenever there is an emergency, the network collapses. So because of overburden or more traffic into the network. So this mission critical communication networks are designed in such a way that you provide enough traffic capacities, and you also integrated into the system are different kind of priorities of different kind of calls, which will always get through even if the channels are allocated. And there are also emergency call facilities available, that even if a channel is busy, everything is busy, if you do an emergency call, you're going to get through by breaking into a different call. So that is it. The third important thing is it has to be secure. So that by secure, there are different levels of security. One is authentication, that the terminal that you are using is actually a terminal of your network, number one. Second would be a level of security. Now, when we talk of level of securities, there are different security grades, and one grade would be that the air interface, that if somebody tries to log into your network, he should not be able to listen to your communication. That is one thing. And the second is that when you have multiple sites connected over long distances, even if somebody tries to get into your backbone, he should not be able to uh, uh, connect and listen or do some fiddling. So that is about end-to-end encryption. Now, all these facilities are required in a mission critical systems. And today, because of the futuristic things which are coming in, we are not only talking of audio or voice communication, we are also talking of a lot of data communication. And people are also talking of video communication now. So when we are talking of a communication network, we will have to see how we can accommodate audio and data to a large extent as on date. Another very important thing is that the system should be allowed to have different kind of call sets. When you talk of call sets, we talk of individual calls, we talk of priority calls, we talk of different kind of group calls, we talk of announcement calls or broadcast calls. So all these call facilities should be available, because when you have mission critical application, it is important that when somebody speaks, a lot of people should be able to hear. So that is also very important, which is not available in a normal private network. And the second thing is, in a lot of new systems, you have a lot of SCADA kind of applications or low data applications. So your system should be capable enough to handle low data applications of picking up some kind of IO data and transferring it to a control room and all those kind of things. So this is about what mission critical communication requirements are as on date. Okay, regarding DAM, DAM is a company founded in 1981, and the good thing about DAM is that all its production is done in Europe, and we are there in more than 60 countries worldwide, and we are a member of the TCCA, or the Critical Communication Association. We are a member of the DMR Association, member of the TETRA associations, and we have provided more than 32,000 channels worldwide, and we have very extensive references in railways and other mission critical customers. About DAM in India, like we have more than 100 systems deployed in this country. And in recently, we started a company called DAM India, which is a joint venture between DAM and Consort to look into the indigenization of TETRA infrastructure in this country, and also look into project management and more engineering, which can be done from India for the rest of the world. So that we are doing it. And another very important thing is as I previously said, that the train radio system, the dispatching system, the softwares which go in for integration with TCMS, ATS, the PAPIS systems are all done in India. So that is the good thing about our company. Okay, so we ended the basic introduction. So we are now going to get into what radio trunking is. See, normally what happens in a radio communication that you have a particular frequency and people will press to talk in that frequency, and others who are there in the channels will be able to hear. Now, the difficult part of this communication is that if one person is speaking in a particular channel, the channel is busy. And unless and until he leaves the channel, others cannot talk. That is number one. And number two, even if other channels are free at that point of time, other people cannot use that channel because he cannot get the third party to go to that channel. So that is the challenge in a normal VHF communication. So it is purely channel based, and even if free channels are available, you cannot switch to a free channel to talk to a calling party. So that is the thing. So from there, the concept of trunking came in. It is basically sharing of channels. In telephony system, the first we had these trunk calls, if you remember, and when the channels between states, interstate communication was less, and we used to book trunk calls, and when the channel got free, you were able to talk to a distant state. So it is from basically the same concept that trunking has come in, and in this, what fundamentally happens is that all the channels are provided to all the subscribers, number one. And there is something called a control channel. So initially what happens is all the radios, when they are switched on, all go into the control channel. So they are locked to the control channel, number one. And there is a lot of data communication or control signaling which happens in this control channel between the terminal and the base station of the infrastructure. And if somebody wants to make a call, what actually happens is that in the control channel, the called party and the calling party information goes to the infrastructure. And in the infrastructure, there is a switch which checks which channel is free and allocates that channel to both the called party and the calling party. And this all happens automatically. So finally what happens is, I want to make a call to you. I dial your number and press, or maybe you just press, and the system checks which channel is free and automatically gets your walkie-talkie and the other walkie to that channel, and you start talking. And after the call is over, this channel gets again free and goes to the total pool of channels. So all radios initially are all in the control channel. So as I said that there is a digital control channel, and which assigns traffic channel to specific radios for a fixed period of time, after which the call is cleared down and a new call is allocated in that channel. If traffic channels are busy, incidentally the calls get queued, and automatically when a channel gets free, you are allowed to talk in that channel. So this is all automated. So this is very important that all radios initially are in the control channel, doing a lot of data communication with the central system, central infrastructure, and the central infrastructure finds out which channel is free and allocates you the channel. So all these things happens instantaneously. All this thing happens automatically. So the only thing is you just press and you just talk, and the channel allocation and everything is done by the centralized system. So that is what trunking is. Okay. Now trunking systems have started evolved in this earth around from 1980s. Initially, it was the analog trunking systems, and now analog trunking systems have migrated to digital trunking system. By digital trunking systems, we fundamentally mean that the modulation has become digital. your walkie-talkies and terminals have become all digital. So in digital trunking systems, what happens is you have larger number of channels, number one. There is a reduction in the wasting time to find an available channel, and it has got interconnectivity with the internet, and it has lesser noise. So, and by this digital migration, so another very important thing is what has happened is multiple sites and could get interconnected each other, and you can have multiple levels of communication for larger distances. Okay, now a fundamental difference between a trunk system and a conventional system. In a trunk system, as I said, that the channels are automatically allocated by the system to the user. And in a conventional system, it has to be done manually by the user. And the call setup time is generally around 500 milliseconds in a trunk system. And in analog system, it is instantaneous. And one disadvantage of the trunk system is that, for example, you have 4 or 5 channels. One channel will become the control channel, and you will get resources from the other 4 channels to be used as traffic channels. In an analog system, there is no control channel, so you get larger number of channels to use. But the difficulty about a analog system or a conventional analog system is that even if the channel is free, you cannot go to that channel and use the channel because the called party will not be in that channel. So that is the problem about analog system. And when you have larger number of users, when you have larger number of distances to be, actually trunk system is the only solution that you have, because trunk system also allows you to connect to any fiber optic bearer or any microwave bearer and have multiple sites, so that long distance communication can happen over a larger area of. Okay, any particular questions you might have about this particular section about trunking system and a conventional system? Okay, I'll continue then. So, as I previously explained, this concept has come in from the trunk line concept of between telephone exchanges. When you have a larger number of telephones, lesser number of lines between the exchanges, and these lines used to be called the trunk lines, and they were allocated depending upon the requirement of the different users. When you have a lesser number of resources to be allocated a larger number of users, you use the concept of trunking. Okay, now see, we have just discussed that you could have very large area of trunking systems in place, and you could have different TETRA base stations installed at different locations depending upon the RF coverage of the individual base stations, and they can all be connected over an IP network. So as far as the user is concerned, he doesn't know where the other radio is, but he just types the number of the other radio and gives a call. It is for the system to understand, depending upon the home location and the visitor location of the other radio, and direct the calls automatically in the network. So as far as you are concerned, it's just like a GSM network. So you do not today know where the other user is. You just make a call and the call lands to him. Now the difference between a GSM system and a trunk system is that it allows you group communication. It allows you different kind of emergency communication channels. So that is a different thing about it, and it also allows you a large number of interfaces. It allows you interfaces to analog gateways from where you can talk to analog radios. It allows you interfaces to dispatching systems or PC-based systems, which are used for control applications for your train movement. It can also be integrated to your telephony systems like PABX and PS10 interconnectivity. And this is how the overall network looks like normally. So, so large area trunking systems are possible, and they are being used in a large number of locations in this country also. And in this, every TETRA base station or any trunking base station would interact with each other and route the calls automatically. So here, it is for the user to just make a call, and that's it. Okay, so we'll just explain this particular slide slightly more. That in this fundamentally trunking system, there is a control channel or which is being used, or which is also called the controller, and you have the different channels. Now the traffic channels are allocated depending upon the usage and the requirement of different users. So somebody wants to make a call, then it will go in channel A, and the second user wants to make a call, it will be allocated a channel B, and all these things are done by the controller through the control channel. Okay, so we have more or less given you a basic outline of what trunking system is, and we'll now slowly get into TETRA. TETRA is an acronym for a technology called terrestrial trunk radio. How this has evolved is there is an organization called ETSI, the European Telecom Standards Institution. So what they normally do is they prepare a draft specifications of every, and it is circulated to all the major users and the manufacturing companies. So after they had drafted the GSM specification, so HC felt that a similar specification should be done for the critical communication users, and then they drafted TETRA. So TETRA is very similar to GSM, except that it has a host of other features which are required by the critical communication users, mainly group calls, priority calls, and dispatch options, a lot of better encryptions. So that is how TETRA has evolved. TETRA has started in this world around 15 years back, and slowly it has gone. It has been deployed in almost every country worldwide. And in India, I think we have more than maybe 500 to 600 different TETRA networks, small to big, very big networks in place, including the police, the defense, different oil and gas customers, port trusts, and mining customers, as well as all the metros in this country use TETRA. So that is about TETRA. Okay, now as I have given you a brief, TETRA was developed by ETSI, and ETSI basically wrote a lot of new features into the GSM specification, and this was created. And this has fundamentally all the facilities of a normal analog radio. It has all the facilities of a analog trunking system, and almost all the facilities of a GSM system. So that is how the TETRA is. And and the mobile and the TETRA phones which are available, or the TETRA walkie-talkies which are available, are today very similar in more or less the shape and dimensions of a mobile phone. Okay. So this has become a major standard, and the very important thing about this particular standard is it is totally interoperable. By interoperability, we mean that if you have a walkie-talkie from any company worldwide, which is compliant to TETRA standard, it will work with any other infrastructure of any other company. So that interoperability is available in TETRA, just like a GSM. You can go to a market and buy any GSM phone. It is going to work with the GSM infrastructure, irrespective of the infrastructure could be of Nokia or Ericsson or whatever. So similar about TETRA, this is the very standardized standard in which all the interfaces are very well defined. So you could have the infrastructure of any company, and the terminals of any other company will operate with this. So that is about the interoperability. Slightly more into details, TETRA is actually 4-slot TDMA, and 4-slot TDMA means that in every frequency of 25 kilohertz, you actually get 4 channels, and in this 4 channels or 4 slots, one slot is reserved as the control slot, and another 3 slots are used for voice traffic or normal operations. Okay, and this is the overall TDMA frame. So the hyper frame is 61.2 seconds, and you have the TDMA individual frames of 56 milliseconds. And each time slot or the modulating bit is around 14.16 millisecond or the time slot. And the good thing about TETRA is that in a one frequency, you get 4 channels. So that is the benefit of TETRA. So a 25 kilohertz channel spots that railway has gives you 4 channels today in TETRA. So this is how it looks like. These 4 slots are sent out, and you get in a 125 kilohertz carrier. This is used. One slot is the control slot, and other 3 slots are the traffic slots. And you could have parallelly three communication channels operating in one frequency pair. And incidentally, it is all this walkie-talkies all would operate normally through a infrastructure or a base station or the TETRA BTS, and the TETRA BTS would be interconnected to other TETRA BTS depending upon the range requirement. And in case your walkie-talkies move out of the network area, go to an area where there is no TETRA BTS available, these walkie-talkies can also talk to each other on something called a direct mode operation, DMO. In DMO, naturally the range is less. It depends upon the RF characteristics of the particular location. But TETRA walkie-talkies can also talk to each other, as compared to a GSM walkie-talkie or GSM handheld, which cannot talk to each other without the infrastructure. So this is an additional benefit in terms of TETRA. So as I said, it is a 4-slot TDMA. Every frequency is of 25 kilohertz. A digital modulation technique called pi by 4 DPQSK is used, and at 36 kbps is the channel speed. And every speed channel uses one channel. And data calls, incidentally, TETRA also allows you data communication because every slot is of 7.2 kbps, and you could actually have multiple slots encapsulated to give you higher data speeds. So you could get actually up to 36.6 kbps of data in a TETRA. The 7.2 kbps in every slot can be aggregated to provide you 36.6 kbps. So in case you have a data intensive application, so that can also be used. Now what are the facilities we provide by all the system? So you fundamentally get individual calls. Everybody has a number. You dial his number and talk to him. You can do telephony calls also through a interface. You could have multiple groups, and they can talk parallelly through different slots. Now, when you were talking of groups, you could have different kind of priority levels for different groups. So maybe some senior people could have a higher priority, and higher priority will be given more allocation of channels, or higher priorities will be provided to their channel allocation as compared to a lower priority group. And there could be something called emergency call also. The emergency call is something in which even if all the channels are busy, one channel would be cleared down and your call will be made to go through. So that is an emergency call. So it is very useful in distress conditions, and so people can break through into a already working channel, and call can go through. So that is about the emergency channel. It is preempting other users and making a call. Okay. And you could also have broadcast call. A broadcast call is something like a normal VHF call in which somebody speaks and everybody in that network listens to that. So that is a broadcast call. Okay. And you also have something called short data services, which is nothing but an SMS. The terminology is different. We call it SDS in TETRA. You type messages and send to other radios. Okay. And today, TETRA also allows you IP packet data. So in case you have a transaction into the IP domain outside your TETRA network, your TETRA walkie-talkies can also use packet data and transfer the packet data to external world. Okay. Now, regarding integration of TETRA to other networks, we can integrate TETRA with existing analog networks, like your existing VHF communication network. That is one. It can also be interfaced to your telephony networks, or the could be an EPBX, or it could be a PSTN direct connectivity. It could also be used to send SDS to mobile networks, in the sense that you could send an SDS, it could get transferred into it and become an SMS going into a mobile network. And you can also do IP data traffic to your mobile networks from a TETRA to walkie-talkie. So these are the different kind of possibilities that you have in a TETRA network. Is regarding the encryption, I think we'll have to define it into three different parts. One is authentication. By authentication, we mean that the subscriber that is using the network is a valid user or not. So there is a mechanism inbuilt in TETRA by which this the walkie-talkie, which is only authorized, will be able to talk to the base station. That is number one. That is authentication. Second is ear interface encryption. Ear interface encryption is what? It is the encryption which is required when a walkie-talkie is transmitting to the base station. So this is ear interface encryption, and this ear path is encrypted. So anybody who's trying to, log in into this network from the airway site will not be able to get in. And the third thing is that, as I said, that TETRA base stations are integrated over a LAN network or a WAN network. And it is that if somebody is trying to tap into the LAN or WAN network, he should not be able to get into it. So that is called end-to-end encryption. So all the three different standards are available in TETRA, and it is also standardized on the different kind of customers. For example, the defense customers have a higher level of encryption that is also defined, and so there are something called TETRA encryption algorithm 1, 2, and 3. So there are different standards which different customers can use. Okay, anything about TETRA you would like to know, gentlemen?
Abir,
Yeah.
Abir, I just wanted to know that in your presentation you have given that in case of no connectivity, means no coverage is available, still we are able to make call.
Yeah, correct. It is basically the TETRA walkie-talkies have a facility called DMO, direct mode operation.
Okay.
So in what happens is the two TETRA walkie-talkies can directly communicate to each other. Okay. It is just like a normal, it becomes a normal VHF radio. Okay. So they are able to talk to each other directly without going through the TETRA infrastructure. So that is the idea.
But still we require some network through which they can talk. If there is no coverage, no network available, how we can talk?
Yeah, because that's what. See, that normally TETRA walkie-talkies will always operate through an infrastructure. So walkie-talkie will communicate to the infrastructure. Infrastructure will decide which channel to allocate, and then it will get the call going to the other walkie-talkie. That is the normal way of operation. But the TETRA walkie-talkies otherwise also have an inherent feature. They will be able to transmit directly to another walkie-talkie in case the infrastructure is not there. You take two walkie-talkies to Mount Everest. You don't have a network there, but they will be able to talk to each other. So that is a facility of TETRA. That is the inherent facility of TETRA.
One more question. Myself, Mohammed Nasir, Deputy CST Construction from Eastern Railway.
Yeah.
Actually, what is the range of this TETRA walkie-talkie? As you were telling, in the absence of network, both walkie-talkies can talk. And what is the maximum coverage area?
See, now there is 2 or 3 things we need to understand. TETRA is available in 400 megahertz onwards. It is not available in VHF. Okay. So in 400 megahertz onwards, the TETRA walkie-talkies have a power of 1 watt to, I think, 3 watts. Okay. So now, depending upon this power and depending upon the environment, you will get a range. What we have seen normally is in a city environment, slightly semi-urban environment, we get around 1.5 to 2 kilometers of coverage between two walkie-talkies.
So means within the range of 1 kilometer and 2 kilometer only we can talk if there is no network.
Yes, correct.
Okay.
And in case you are using static radios or mobile radios, TETRA mobile radios, which generally have a power up to 10 watts, then the range would increase. You can get up to around, I think, 15 kilometer point to point. Okay.
15 kilometer means if you buy the walkie-talkie of higher wattage.
And TETRA also has mobile. If you see, car mount radio. So static operation. Okay, now we'll go back.
I think, Abir sir, we can add one more thing here. In Western Railway, Mumbai, we are covering the area from Churchgate to Virar, which is around like 70 kilometer, and we have deployed 6 number of base station. So by 6 number of BTS, we are getting the coverage in 70 kilometer.
Right. Okay.
Yeah.
So we will now go into the specifics of the system of the DAM tetraflex system. Okay. Now, when we talk of infrastructure, as I said that TETRA is basically infrastructure product in which you have base stations all interconnected over an IP network, and these are the different kind of interfaces which are available. You could have log servers. Now, what are these log servers? They record all the calls that are happening. They also record all the SMS and SDS that is happening. So this is a logging function. So all the calls which are happening in the network gets logged into the server. Then you could have different gateways. Now these gateways are required for different applications. We'll come to that slowly. You'll come to know why gateways are required. You could have dispatchers. Now what are the dispatchers? So basically control room dispatchers, PC based, where he can make group calls, individual calls, and all those kind of functionality is available at the PC end. And so this is about what a whole network would look like. Now the good thing about the DAM infrastructure is, DAM infrastructure, it is a distributed architecture. By distributed architecture means that there is, you could put this anywhere in the network. The gateways and the dispatchers and the base stations could be put anywhere in the IP network and start operational. Unlike the centralized architecture, what used to happen is, you used to have a central switch, and normally all the infrastructure equipment would come and get connected at the central switch, and all the routing would to be controlled by the central switch. But the good thing about the DAM infrastructure is, it is a totally distributed architecture. You put your base stations and dispatchers anywhere in the network, and they will start operation. You don't have to come back to the central switch for any call routing and everything. And now the difference between these two is that in case there is some issue in the central switch, then the whole network collapses in a centralized architecture. Here, if even there is a particular failure in a particular node, that node is out of the network, the rest keeps on operation. So that is the good thing about the decentralized architecture. Okay, so it's just adding what we have said here is, it is a totally distributed in which all the nodes are there in the IP domain, and all the vital information about the network is continuously getting shared and replicated in all the other nodes in the network. So in case any particular node goes down, it is just that that node will start functioning. The rest of the network will keep on operation. So that is a good thing about a distributed system. So there is no single point of failure, and all the local and data traffic will keep on happening without any interruption in the system, and all the features remain intact. And another very good thing is, when you want to expand, you just plug in the new node anywhere on the IP network, and that's the end of the story. You don't have to route all your calls back to the central switch. So it is just plug and play. So it becomes much easier to handle this kind of network. Okay. And now another very good thing about DAM is that DAM provides you indoor base stations as well as outdoor base stations. Indoor base stations are normally, you require a air conditioning environment, and you need to run a lot of RF cables to the tower top and put the antennas there. The second option today, which is you must have seen in all the new LTE and GSM networks, they are putting small base stations at the top of the tower itself. So TETRA base stations are very compact, very small, and they are tower mountable. So you can put this particular base station at the top of the tower. So in this, what happens is you save on the air conditioning and the room and everything. And also because of the RF cable requirements is not there, or it comes very less. So you don't lose on the RF power. So you get a better gain through this outdoor BTS. And another thing is there is possibility of this TETRA BTS to share frequencies or with other BTSs. That means you could have multiple sites operating on the same frequency by frequency sharing. So DAM TETRA outdoor BTS BS422 is the first TETRA BTS which can do frequency sharing with other BTS in the periphery. So what happens is this way you save on the frequency spectrum cost. And incidentally, this particular TETRA BTS is a software-defined radio. So you could use it for TETRA as well as for analog, as well as for DMR, Tier 3. So it is all programmable. So the very good thing about this is today maybe you go in for a TETRA, tomorrow you might shift to DMR, or maybe you say, no, I would like to use it for analog. So all this thing is possible in the same BTS by just software programming or licensing. And this is about the indoor BTS. So these are used in an indoor environment, normally in an AC environment. And from here, RF cables go out to the tower, and you put tower top antenna systems. So that is how it is. And this can have up to 16 carriers. By 16 carriers, and each TETRA carrier, as I said, can handle 4 channels. So up to 64 channels can be handled by this particular BTS if you want. And this could be a single site system, or as I said, you could have multiple of the sites connected together on IP backbone, providing you a multi-site system covering a larger area. For example, in the metro, we are presently, for example, I remember we are doing Mumbai Metro. Mumbai Metro, in one particular line, we are putting 6 BTS and connecting them over a fiber backbone, covering coverage of, I think, around 30-40 kilometers over the stretch. So it is that how it is configured. Okay. Now we will go into something more interesting, more relevant to you. What we have done in Western Railway. Okay, the Western Railway, if you look into the system, what it actually does is you get a push-to-talk communication less than 300 milliseconds is the time. So somebody or the driver in the train presses, he is immediately get access to the controller within 300 milliseconds. And same thing about the other station master radios and everything. Okay. Group calling is possible, that is one to many. So you have different groups, and in groups, different radios are already marked in that group. So when somebody wants to make a group call, it lands in that group. And there could be multiple groups. You could have operational group, you could have a station master's group, you could have a engine drivers group, something like that. You could have private calls. Some particular train driver wants to talk to a particular station master, could be a private call. You could have emergency calls. Something has happened, all the channels are busy, you are not getting access. There is emergency button on every radio. You press that button, you get access. You can do small, short data messaging is possible, and it is all secure. Secure in the sense it's all authenticated radios. It has encryption inbuilt in it. So if somebody wants to just go to that frequency and try to receive it, even if you have the same radio, you'll not be able to do it. So that is what it is. Okay, so the communication pattern that we are providing them is driver to guard communication, train controller communication, cab to cab communication is available, and broadcast call is there. Data communication is being provided, and there are dispatcher workstations which are there at the controller from where the dispatching and the call control happens. It is being integrated to your existing TMS system. It has an interface for the train mode PA system so that the controller and the dispatcher, if they wants to make any train PA call, it is possible. It has a network management tool. This network management tool, what it does is it tells you the overall status of your network and overall status of your terminals also. So which nodes are available now? What is the traffic loading on different BTSs? How many walkie-talkies are registered or switched on at that point of time? What is the traffic calculations happening? Are there any channels or any particular BTS getting overloaded or something? So all this information you get into network management. Second thing is, in case of any failure, you can have a diagnostics of what were the alarms which were generated. Was it a power supply failure alarm, or it was an antenna alarm, or something like that. So those alarm information also comes in your network management. Besides this, it has got a voice recording system. So whatever calls are happening in the network gets recorded in that particular database. And the coverage, as Vikas said, is from Churchgate to Virar. Okay. And it has got a very beautiful MMI, which has been created, man mission interface for the train cab radio. Okay, about the architecture, as I said, there are 6 different sites and at different locations. These are all outdoor BTSs installed on top of the towers, connected to antennas, and running on 220 volts, each of them, all interconnected on a OFC backbone. And at your control room, you have the PABX gateway. From if some driver or some walkie-talkie wants to make a PABX call, it is possible. And telephony network users can also get it through this PABX into the radio. And there is a voice recording system. There is a TMS gateway. And the dispatchers are available and the network management is available. Okay. Any questions on this particular architecture, gentlemen?
Abir, I just wanted to know that you were telling that your application is with metros as well. Now, most of the metros are running underground, right?
Yes, correct.
But we cannot provide these towers underground. So
Okay.
how we are able to provide these coverage then?
Yeah, in underground, sir, what we do is there is something called a leaky cable solution. Okay, so in this, what happens is the TETRA BTS power output, instead of radiating into a antenna, gets radiated into a cable. Now, this cable is run through and through the tunnel, and this leaky cable.
So we have to provide the cable as well.
Yes, that is the way it is done. So instead of the antenna, this TETRA BTS output is dropped into this leaky cable, and those leaky cables are run on the tunnel faces, and walkie-talkies and train radios, whenever it communicates, that signal is picked up by the leaky cable and brought to the TETRA BTS. Number 1. Number 2 is...
So it is going through cable.
It is going through cable, yeah. It's called RF.
And how this cable is connected? Just one second. How this cable is connected with this walkie-talkie?
Cable is not connected to walkie-talkie. It's just like an RF cable, sir. It is just a pure RF cable. Only thing is, on this RF cable, inside the RF cable, there are some small slots. Okay, and through these slots, radiation happens. So it is a leaky cable. So the whatever TETRA power is being radiated is leaked throughout the cable. So a train walkie-talkie, wherever it is within near to that cable, will be able to receive that leaked signal from that cable and able to receive. And when the walkie-talkie presses through this leaky cable, picks up that signal and it is brought back through the cable to the TETRA BTS, and it receives the signal.
And what is the range of this cable? From how much range it can it can take the signal from the walkie-talkie?
Right. Good question. Sir, this is slightly difficult to answer. because it requires some calculations regarding the kind of tunnel it is and how big the tunnel is. Normally, 1.5 kilometer of coverage is possible, and because these leaky cables are also available in different sizes. You could have, half-inch cable or a 7 by 8-inch cable or 1/4 inch cable. So these cables have to be, designed. This network has to be designed. And the second thing is, after every 1 kilometer, there are something called, RF amplifiers. Okay, bidirectional RF amplifiers. They are also put between the cable so that this range is extended by another kilometer. So it is a design which is done. But everywhere in the world, in all road tunnels and railway tunnels, this is the way it is done.
Okay, is this the standard practice for metros, underground
Yes,
metros? This is the standard practice.
Not only metros, any tunnel anywhere in the world or in enclosed space. For example, in a building also. For example, there are very big buildings worldwide in which the RF signal will not go into the building basements and all those places. So there also they put these leaky cables to transfer the signal in the basements and underground areas. That is the only way of doing it, sir.
Okay.
Right.
Thank you.
Thank you. Okay, we'll go to the next slide. So this is the network layout. We just explained this.
Just interrupting you. Just
Yeah.
in continuation of Mr. Vijay, see, I want to know is when you are providing the leaky cable, we can talk over the walkie-talkie also. That walkie-talkie will be able to connect with the leaky cable network.
Yes. All walkie-talkies, any train, cab radio, everything. What happens is the RF signal which is radiated from the walkie-talkie is picked up by the nearest leaky cable. Okay, and that signal is goes through transmitted through the cable. It's like a what do you call it? It's like a duct. Okay, it's like a duct. So this cable would act as a duct or a waveguide. So when the walkie-talkie presses, that signal through the leaky cable pore goes into that RF duct and goes back to the base station, and the base station receives the signal. And on the other side,
I think, but the range may be the very less.
Range, as I said, normally 1.5 kilometers of leaky cable. You can have direct leaky cables up to 1.5 kilometer on the tunnel face, and walkie-talkies anywhere in the tunnel will be able to communicate.
So from the leaky cable, that walkie-talkie can be up to around 1 kilometer, 1 to 1.5 kilometers.
Not from the leaky cable. See, the tunnels are normally very small, sir. Tunnels would be let's say about 30 feet or 40 feet. Okay. So the walkie-talkie inside the tunnel would always be within 10, 15 meters, 20 meters from the leaky cable. Okay, whatever you do.
Okay, right.
So this signal would be picked up by the leaky cable and brought to the base station. And base station to the leaky cable distance normally is around 1.5 kilometer. And if you want to have larger tunnels, then you put amplifiers in the middle and extend it through another leaky cable. So that is the way. Okay.
Abir, what is the frequency range over which this communication takes place during the tunnel?
So it depends on whatever frequency you want. It depends. See, TETRA normally in India in metro is all 400 megahertz. So everywhere in this country, in underground, we are using 400 megahertz. But as far as
this is VHF range, right? No? VHF range or UHF?
Yeah, UHF. But
UHF range.
As far as the leaky cable solution is concerned, it is independent upon the frequency. It depends upon the cable. When you buy a cable, you have to. Some cables are available from 1 megahertz to 1 gigahertz. Some cables are available from 1 gigahertz to 2.1 gigahertz. It depends. Like you buy the cable accordingly, and you decide on the cable thickness accordingly, and then you deploy it. Because in some tunnels now they are also using not only they say I would like to have VHF communication, I would like to have LTE communication, I would like to have GSM communication running on the same cable. Okay, so you buy a cable accordingly.
Okay. Now, just I wanted to know that is it some special kind of cable? This leaky cable, I have heard first time this word. So in your presentation, are you able to show me that actual pic of that cable? Is it available with you?
At the end of the presentation, I will find out something. I'll show it to you, sir. Okay. It is not
Okay.
a part.
Is it some special kind of cable other
Yeah,
than
yeah,
these
it is,
copper cables?
yeah, it is a special cable. It is a special cable.
Okay. Okay.
It is a very,
Thank you.
it is called a leaky cable or a radiating cable, or it's also called a slotted cable. So these are the, and if you just type a leaky cable in your internet, you get a lot of cables, RFS or anybody. So there is a separate division which handles this kind of cable. Okay, now we come to this. Yeah, we come to this train radio system. When you see the train radio, fundamentally there are two parts. One part is the RF radio, which is actually communicating back with the infrastructure, and the second is the man-machine interface. So what we are now showing you is the man-machine interface. It is a 5-inch TFT screen, and it has an emergency button. It is available up to 85 degrees centigrade. It is actually it is compatible to LTE also, and it is flash proof, and you get a reading angle up to 160 degrees. So this is a specific man-machine interface developed in India by Consort, and extensively being used in a lot of projects. And we are incidentally also exporting it to Bangladesh and other countries to operate within an LTE environment. So this is how it looks like. You get the time and everything. So, and you can select different numbers and make those calls from here. And whenever somebody makes a call, you get his ID and everything. And you see that the red button is there. You press that button. This is how it looks like. And there's the emergency key. There are different keys which can be configured depending upon your requirement. There's a power on off key, and dedicated controller keys are also there. In case you want to speak to a particular controller, you just press that button and you get connected. And otherwise, you can dial any number or any ID of another radio and make that call. So that is also available. And in case you want to make a PA call, you can press the button to the PA call, because this is also interfaced with the PA system. So this is the actual picture of your location installed in a train radio. So this is how it's looking like. Okay, and these are the different base stations, and the indoor base station and the outdoor base stations, and the soft switches and the different gateways. We have already discussed slightly more in this. Okay, so I am not sure if you see that there is a DAM base station. I think this is a Mumbai installation only. Yes. So you see that the small base station there, that is.
Yeah, sir. So this is like Mumbai installation for Western Railway we did.
Right. It's a very small compact base station. You put it anywhere, it will start working. Okay, regarding the terminals, there are different terminals available. One is, as I said, the static radio or the mobile radio, which you can also install in vehicles, and these are the handheld terminals. And these handheld terminals have a inbuilt GPS. So at your control station, you can actually find out where the terminals or the person is moving in the environment. And it is an end-to-end encrypted terminal, and it has also got an integrated Bluetooth option. So if you want to use any Bluetooth device on your and receive and talk, you can also do that through this. Okay, this is the voice and data logging. So in this, actually, what he's trying to tell you is that who initiated the call at what point of time, and how much time he spent in the communication. He was registered with which particular BTS. So all this information comes, and these are called the CDRs. And you can also record all the voice calls which are happening. So this is the small screenshot of that. And this is the dispatcher which is there. So this is important. Like this is the, I think this is the Mumbai dispatcher, Mumbai Metro Rail dispatching dispatcher, in which you have something called a communication view, alert view, and a train view. So what is the communication view? Communication view allows you to make calls. A different kind of calls are possible through the communication chapter. And in this, you have individual calls, group calls, telephony calls. All those kind of calls can be made through this. And in case any call comes to you, you also get it in this particular view. Okay. And you also get a record of all the previous calls and everything. And there is a kind of phone book available, as you can go to that phone book, any call by one press. So that is it. The alert view is basically, you know, if the train, this is specifically more in terms of metro applications. Metro wants us to monitor different alarm status of the train. So whenever there is an alarm in a train, those alarms automatically come at the alerts view, number one. And number two is all these metro cars have something called PEA, passenger emergency alarm. So, so if there is a passenger presses a button in the train, his call is directly routed by the TETRA network back to this dispatcher. So he gets it in this alert view. So this is a PA call, so that comes here. Second is if somebody wants to make a PA call from the dispatcher, so because the TETRA is also integrated to the PA system in the train, so he can make that call from his dispatcher. And the third is the train view. In this, you actually come to know where the train is, and you can accordingly make the calls to that particular train. So depending upon your IDs and everything. Okay. Now we come to the different solutions which are there. So one is metro rail is very specific about coverage. So in this metro railway, what we have to do is we have to provide redundant coverage. So normally what happens is even if a base station fails, neighboring base station should be able to cover that particular area. That is one thing. And you will have to have very good audio quality and RF signal throughout the network. So that is also checked. And the requirement, another requirement is instant communication from the driver. So based on this calculation, traffic calculations are done to ensure that channels do not get busy for this instant communication. And there is also something called location-based calling and functional addressing, which is basically that I should be able to make a call to a particular train depending upon its location. And for this, what happens is that we have integration with the ATS system. And from the ATS system, we come to know where the train is. And based on the train, the IDs of the train radios change. And based on that, the calls are made. Okay. And the very important ability is that, you know, making public announcement calls from the dispatcher. It is all done through the TETRA BRF. So what the dispatcher person does, he just selects a train radio and makes a PA call. And this goes through the TETRA radio in the train, gets into the PA controller in the train, and onwards to the speakers. It is also connected to the TCMS system, so that in case of any alarms which happen in the train, those alarms are automatically transmitted by the TETRA bearer back to the dispatcher for the controller to take any action. Another important connectivity is telephony system, and the second is the train station PA system. No, sorry, not train, station PA system. So the engine driver, if he wants to make a call, or any TETRA wants to make a call, he can directly announce into the station PA system. That is also available in all metro rail. So this is an important feature, and it actually is done via the telephony network. So the TETRA call goes into the telephony network, and the telephony network is integrated to the individual station PA system network, and it is by that it is done. And all voice and data gets recorded into something called a centralized data recording system, which is there in the OCC and BC. So this would be something overall solution for a metro rail, or for that case any railway network. So you have the trains, and in these trains you have the train radio control panel or the man-machine interface for the driver. This is connected to the actual data radio, which is the TRS 3900, and this is there in the train. And you have this different TETRA base stations in the network, reducing and communicating. And on the IP bearer, you would have at the OCC and BCC, you will have all these integrations available. You have the automatic location system. So all the walkie-talkies and the train location would come to these automatic location systems. You actually know where your train is or where your walkie-talkie is. You have the dispatcher points or the controllers from where they can make calls to the different terminals. Integration is done to the rail signaling system or the ATS system on one side, and also it is also integrated to the master clock system, so that the clock timing even through the all the radios and everything is there. And sometimes in some stations, because of coverage issues, we also have put some small repeaters to provide indoor coverage inside the station from coach levels and platform levels. So that is where the small BS422 modules come in. And walkie-talkies and all those things are given to different users. Another important thing which is now available is there is a small smartphone application available. So in case you have a smartphone and you want to get logged to a TETRA network, and that is also possible. So if you have a smartphone, you get a small application, and you can from your smartphone also get connected to a TETRA walkie-talkie. So that smartphone PTT application is also available now. So we have also now slowly coming on something called light rail, which is also a requirement coming up in this country, for where the requirement is not that high in terms of integration and everything. They would just like to have voice calls, and they would like to have communication with the PA system. So TETRA is also being proposed for the light rail or the metro rails, which are coming up in this country. It's similar in nature, but the functionality requirements are less in this particular light rail. Okay, this is the same architecture, except that in this we'll be using more in terms of outdoor base stations with smaller towers and covering that area, because putting up very big towers inside the city might be very difficult. So smaller towers with small BTSs, outdoor BTSs, and covering that whole area, and integration with the different subsystems. Okay, and regarding we are working in the second rail project in Delhi now, in which they are deploying a LTE network, and in that LTE network, I think it is of Nokia, and the dispatchers and the train the train radio and the station radios are being provided by us. And it has also these interfaces with the signaling and interface with the public announcement systems, public information systems. All the alarms are being transmitted from the train through this bearer, and it is compliant with the future rail mobile communication system, which is coming. So that is also being done by us. Here, everything is the same, except that instead of TETRA, the bearer network or the radio network would be an LTE network. So here, the base stations will be LTE base stations. Otherwise, the other equipments in the network are the same. The only thing is the radio network here is being replaced by TETRA by an LTE core network. So that is the fundamental difference in this particular solution that is being provided. Okay. So as far as we are concerned, a small thing of this that we have an indigenized design and development center in this country. I'm providing a lot of software-based applications which is required for interfacing with different subsystems. And we are the only Indian company which have been RCS blood tests which has been recently been conducted in and in this basically integration between narrowband and broadband technology is happening. And we have more than I think 110 installations of big networks in this country as on date. So we provide you a direct service in the country. So this is the indication of our valuable customers that we have. We are there in Nagpur, Pune, Western Railway, MMRDA, and all this Kawasaki, Alstom, Siemens, they are also EML. So they are using our radios. Besides this, we are also in international projects from this company. We are doing handling Dhaka Metro and Mauritius Metro. And as far as the references in different other customers, which are our big customers that we have. So Adani, all the ports, we are having our TETRA networks. Tata is using our network. Jindal, Maruti Suzuki, Naira Energy. So it is a few of those customers that we have. Okay. So thank you. And any questions? Because after this, we'll have one or two small videos they would like to show you. So you could ask me any questions on this TETRA network.
Yeah, can I ask one question?
Please, please.
Regarding the signal interface which you showed some time back, can we anywhere have you used this signal interface for conveying the information required for cap signaling?
No.
No.
Cap signaling we have not done. So we have not done that.
But just to add, Abir, we have done testing in the lab with Siemens for ETCS2.
सुरेंद्र सिंह जी बोल रहे हैं
Hello.
कुंडला में थे ऑरिजिनल में है
We are getting your voice.
ETCS2 testing we have done, right?
मैं प्रदीप कुमार हूँ DPCB मिशन की DFC में था भी मैं रेडियो फाइट हो गया आपकी मेरे साथ हमारे यहाँ पे बात हुई जब आप कुंडला में थे रिगार्डिंग
Sir, your voice is very low.
तो अभी मैं रिप्रेजेंट हो गया हूँ मेरा 5 साल पूरा हो गया डिप्रेशन मैं रेडियो में आ गया जी
Go ahead, Abir, go ahead.
आपको फिर दोबारा डिप्रेशन दे दिया बिना कूलिंग पीरियड के
Hello.
Yeah, any other question?
अच्छा
Yeah, you were saying that you have tested it somewhere. Is it under testing?
We have tested the TETRA to carry ETCS2 signaling.
मैं रेडियो में
Europe,
में आ गया
There is some disturbance. I think somebody has forgotten to mute.
Yeah.
मैं एक डिवीजन में एक नई पोस्ट सीनियर डीएसटी क्रिएट कर दिया फील्ड में
Hello.
Sir.
पहली पोस्टिंग फील्ड में नाम तो सीनियर डीएसटी है गाड़ी है ना ऑफिस है
I request all the participants to please mute their mic.
I request senior DST CPU, please mute your mic.
भाई सही है वो तो खाली मोटी ऑफिसर है ये सब पोस्ट
मिश्रा
है फिर बाद में इसको विड्रॉ कर लेंगे
सर
मिश्रा
जी सर
सबको म्यूट कर दो
ठीक है
जहाँ कुछ नहीं
हाँ अमित now you can continue.
Thank you, Vijay. नहीं वही I think मतलब it has been tested somewhere, ना? You told.
Amit ji, the scenario is that we have done testing ETCS2 data over TETRA, right? So this has been tested with Siemens, in Europe.
So is it approved somewhere
But
for usage?
It is not deployed widely because mostly ETCS2 they are using currently kind of a Wi-Fi system, right?
Yeah, but at some places it has been used not in the name of TETRA, but in the same frequency range, but for 400 megahertz.
Yes.
It is already under use by some railways.
Yes.
Especially in fallback mode.
Yes, it has been used. So it has been used in some countries, but not in India. We have not deployed full signaling over TETRA in India, right? We have not done that.
Okay, but it has been tested.
What we are mainly doing is carrying some critical signaling alarms, like Abir said, over TETRA from the signaling system. So that we are getting from the train control management system, which is in the train.
Yeah, but of course you can maybe you will not be able to do it with that mobile tower thing. You will require this leaky coaxial throughout the system if you want to use it for carrying cap signaling information. I think that will be required.
Actually, if it is outdoor, then we typically put antennas, right? And if it is tunnel or underground, then we put
not only in underground scenario, but to make the communication more reliable, especially when you are going for mission critical information. So wherever it has been deployed, even for the viaduct sort of scenario also, they are using leaky coaxials only, not the tower thing.
Some places they are using leaky coaxial because typically antennas will, sometimes they are not able to reach everywhere. So
yeah.
They
And also weather conditions and all those things may also affect the working and reliability.
Yes. So that is completely up to system design. That is not an issue. Yes, sir. Correct.
Okay, thank you.
Abir,
Anything else?
just wanted to ask some question that you
please.
have given some features about this TETRA network. What are the advantages? Is there some disadvantage of this TETRA network as well, or something where it is lacking right now?
See, as far as TETRA is concerned, it is fundamentally a voice solution with some amount of data capability. But it will not handle video to a large extent. So in case you have a video requirement, video transfer requirement and everything, TETRA is not the correct solution for you. So that is one disadvantage about TETRA. Because it is a narrowband technology as such, and it will not allow you to transfer too much of video. You can send some small pictures and everything, that is possible, but video throughput is not possible in TETRA. I think that is a major disadvantage as on current requirements of some customers.
Any
Yeah, major disadvantage is that TETRA is mainly a narrowband system, a narrowband data system, and that is the reason why there is now an upgradation path which is proposed in the standardization body to integrate it to MCX, and MCX can run over a LT network or a 5G network also. So I think one big limitation of TETRA is that it is not a wideband data system. This is, I think, the only big limitation.
So why we are not shifting it on gigahertz? Why it is only in megahertz? Because at gigahertz we are going to get some more bandwidth.
No, it is not an issue of megahertz or gigahertz. As you are saying, it is mainly an issue of channel bandwidth, right? So
at higher frequencies you will be getting more channel bandwidth, na?
No, even in lower. So for example, just to give you an example, TETRA operates in 400 and 800, right? But my channel bandwidth that TETRA uses is 25 kilohertz. So one carrier, if I deploy in TETRA, is 25 kilohertz, and it will give me 4 voice channels, 4 voice or data channels, right? But on the contrary, you can deploy LTE in the same band. So you can also deploy LTE in 400 or 700, like we are doing now in railways in 700. and but the bandwidth allocation for that is 45 megahertz, correct? So therefore, it is allowing for greater data transfer, basically.
So is there any plan for shifting in gigahertz frequencies in near future?
Sir, actually, gigahertz, see, ultimately what is happening is that, yes, 5G communication is all going into, like 2000
2.3.
megahertz upwards.
Yeah, 2.3 gigahertz
Like
around.
3.3, 3.5, 3.5 is now what they're talking mainly about 5G, right? So
Right.
the problem with that band is that the coverage becomes very small.
That's why they are going for micro.
So coverage becomes very small. So basically, it is like a hotspot, right? It is like a Wi-Fi hotspot. So transportation and all, that is why they are preferring ki you go to LTE or you go to 4G or 5G, but you still remain in the UHF band, because 700 megahertz will still give you reasonable coverage, right?
Right.
That is why Railways has fundamentally pushed for 700 megahertz, and they have got it also now, right? Yeah.
In your
Thank you.
system, how many users can simultaneously talk in one particular cell?
Abir, you want to take that one?
See, as we said, that every TETRA carrier of one frequency pair can handle up to four channels or four slots. So, and you can have multiple carriers on one side. So you could have, for example, a four carrier system. So if you have a four carrier system, you get 16 parallel lines of communication. Or not 16, but 15. One becomes a control, you get 15 channels. Normally,
because bandwidth you are having is 25 kilohertz only, na? So one channel will be at least 5 kilohertz, I suppose, right? One channel
25 kilohertz per carrier, sir, we are taking.
per carrier. Okay.
Yeah, and one carrier gives you four channels. The first channel is control, and less three.
Yeah, that is through TDMA you are getting four channels,
Yes,
right?
yes, correct.
Yeah. And
So
and what is the bandwidth which you are having at 400 megahertz?
we are
36.6 kbps in 25 kilohertz.
yeah.
No, that is the data transfer rate which you are talking about, no?
Right.
No, what I am asking is, what is the bandwidth which is allocated to you at 400 megahertz? What is that bandwidth which you have?
So every frequency pair is of 25 kilohertz, as I said, and you could actually get 5 carriers depending upon WPC requirement. Like in different metro, so we get five carrier frequencies
So maximum 15 to 16, what you said, simultaneously calls.
But our system can go up to, as I said, 16 carriers if you want. But normally you will not have that kind of intense networks in a particular place. So 16 carriers is 64 channels almost. So you will not have that kind of capacity required.
Okay. Why I'm asking, I was asking is कि मतलब for our maintenance purpose also we are using Wi-Fi's. So is there any possibility of using your system for that sort of maintenance? But that may not be possible, because for maintenance purpose a large number of sets will be required. So your system may not be able to support that sort of high user requirement maybe. So it is basically between train and the control scenario, as you have used for in Mumbai suburban, right?
No, not only that. If you look into the police networks, they all use TETRA networks, and they have capacities of 1,000 terminals, 2,000 terminals operating in maybe in a small area. So systems can handle. It depends on how, because say it is like this. If you go look into the traffic calculations, and if you go into the airline C calculations, you can actually support a huge large number of subscribers, because all subscribers will not be parallelly talking at all point of time.
Actually, police network is a bit different because they are basically in broadcast mode in most of the time. At most of the time, they require your broadcasting services. But for railway scenario, we require one-to-one communication.
No, you
So the
normally
channel requirement will increase. In broadcast mode, definitely the channel requirement will be less because in the same channel you can transmit n number of users.
yeah, correct. But how many users do you normally use? How many users?
Sorry?
How many users you are thinking of? Like would like to use a system?
For example, in one station itself, there may be some from one department. We may be having at least 5 to 6 persons at one point of time, and similarly, there are some 4 to 5 departments who are working. So maybe per station, 20-25 users may be there, and at some point of time, at the time of blocks and all, they may be talking to each other regularly. So that at one station, and one station to another station distance is not more than in some cases 2 kilometers to 2.5 kilometers in suburban. So that is the thing. And at how much distance can you reuse your frequencies?
Normally, frequencies are used after every 30 kilometers,
30
depending upon
kilometers.
again the tower height of the tower. But normally 30 kilometers is good enough. 30-35 kilometers.
But in case of just Western Railway, you told that you have used 7 towers for 70 kilometers.
Yeah, correct.
So why did you require those 70 towers? In that case, 30 kilometers is the coverage of one tower. Then
No. It is see, it is like this. Frequency reuse is different and coverage is different. Frequency reuse means the same frequency is being reused after how many sites. And when you're talking of coverage, you mean that what is the coverage of one particular base site? So if
okay.
you're talking of,
So ma'am, you mean to say that alternate in the adjoining cells, you cannot reuse the same frequency. At least one set difference is required.
yeah, minimum one karna chahiye. TETRA talks of 5, but it doesn't happen. But normally, at least 1-2 sites baad you can use the frequency.
Okay. One. So that way. Okay. That is the thing. Okay. Thanks.
So anything else, anybody?
Yeah, Dharmendra Singh over here. I just wanted to ask regarding this LT. At what stage are you in LT deployment? Have you deployed somewhere LT?
Right, I will ask Devdas to answer this.
Sir, LT, basically, we have been working on LT, indigenous LT development for the last 2 years, right? The first deployment that is currently undergoing is for an overseas metro project, right? But just two months back, we did some testing in Europe for the FRMCS, which is the new standard, right?
Yeah.
So for FRMCS, we did testing with all the other vendors.
Yeah.
So in India, it is not deployed in railways or metros yet.
Yeah.
But we are one of the only indigenous companies who has been working on all products. So not only so for example, we are not manufacturing the radio, like the RAN equipment, right? Because RAN, some companies in India are already working, like Tata is working and others are working, right? But we are working on the MCX, which is basically all the mission critical X,
Yeah.
the application service, and also the train radio, the handsets, and also the entire dispatching system for the railways. So that is basically our expertise and our product.
Okay.
So
So,
yeah.
uh, so you are meeting the FRCAMS standard. So what is the means? Have you conducted trials for MCX also?
Yeah. MCX trials we have done. We have done multiple trials, not in railways per se, but
Okay.
in various other environments we have done, sir. We have done.
Okay,
Abhi,
then
over to
I'll ask Vikas to take over and show the small video that we have about Western Railway to conclude this presentation. And I would like to thank everybody for their time and giving us the opportunity to discuss and talk about TETRA.